So now that you've had a chance to see what the executor interface does, let's take it to the next level, and we'll talk about the executor service. And the executor service is also an interface, but this interface has a lot more powerful features than the executor interface. So first and foremost, executor service extends executor. So we have the executor interface with this single method execute, and now we've got the executor service interface, and you can see there's a boatload, lot more stuff here. Obviously, we also get the execute method too, but we also get these other methods like submit and invoke all and invoke any and all this termination stuff. Some of the methods are used to submit tasks, and unlike execute on the executor, which was a one-way call, for the executor service, you can also use it for two-way calls. So calls where you're expecting a return value to come back. And then the second set of methods are really there to manage the life cycle of tasks and worker threads inside the executor service. So these are for terminating and managing the life cycle of the executor service. The executor service is commonly used with other stuff. So we've already talked about runnable. Typically, if you're using executor service, however, you're not using runnable. You're probably using callable. And as you can see, it's a little hard to see here from this structure diagram, but callable is parameterized by something of type V, and it will return, call will return a result of type V for value, whereas run just returns void, or doesn't return anything. It has a return type of void, which means it's the no-op return type. There's also yet another method called future, and we'll talk about that in a second. So we already discussed runnable. It doesn't return a value. It's a one-way call. It's a functional interface. It's a one-way call. Callable is a two-way call where it returns a result. It's also a functional interface. And we typically use this to run async tasks where we expect results to come back. And the pattern that's implemented by this particular mechanism, remember we talked about executor and how it implemented the command and command processor patterns? Well, executor service can be used to implement the active object pattern. And this is a pattern that appears in the POSIT2 book. And basically, this pattern decouples the thread that invokes a method from the thread that executes the method. So one method can be invoking methods. So one thread can be invoking methods on an object, and there could be one or more threads inside that object that actually execute the methods. And this is a very popular pattern. You see this in a lot of frameworks and a lot of languages or toolkits like Akka, which are based on the so-called actor model. So the actor model implements the active object pattern. Very, very, very popular pattern. And it appeared in the POSIT2 book. You can take a look here for more information about that. The third interface that I want to draw your attention to is something called the future. And this is a really interesting mechanism. I'll spend a little time trying to explain it because it's a little bit non-intuitive at first, although once you see the metaphor, hopefully it'll be more clear. So a future represents the result of an asynchronous two-way task. What does that mean? Well, we already know a two-way task returns a result. And we know that if a task is asynchronous, it'll run decoupled from the calling thread. And if you have something that runs in the background, decoupled from the calling thread, and you need to get a result back, then you need to have some way to represent that result while the thread or threads that are doing the computation on the task are busy running concurrently in the background. And that thing is called a future. Now, you've probably all experienced futures in everyday life. So if you ever go to a restaurant that cooks your food to order, like, say, a Wendy's, then when you go to order the food, especially at the counter, when you go to counter service and you order the food, you don't just stand there waiting for them to cook your food, because that would slow things down. They wouldn't be able to get as many people through the restaurant. Instead, what happens is they will hand you a little piece of plastic. Looks like this typically. It's called a table tent number. And that is your future. That tells you and whoever is the server or the service who's cooking your food for you, that when your food has been finished cooking asynchronously, that that's the way they're going to get your food back to you, as opposed to that food to somebody else. So what will happen is they'll keep track of the number, and then when the food is done, there's typically two ways to redeem that future. One way to do it is for you to walk back up to the pickup window and say, "Hi, I've got order number 12. Here's my table tent number. Can I pick my food up?" And if your food has been cooked, they'll say, "Sure," and they'll give you the food and take your table tent number. If your food is not yet cooked, then they will say, "Sorry, it's not done yet." At that point, you have a choice. You can either stand there and block, or you can, time out and go off and do something else and come back in a few minutes and try again. And that's kind of a polling model. And you can decide how long you're going to do something else between checking back to see if your food is ready. So that's kind of a polling model. The other model is a callback model. And you'll see this at a lot of restaurants, like, Frothy Monkey or whatever, where you go and you order your food, you get your table tent number, and then you go sit down somewhere, and when your food is done, they will run it out to you and find you and give it to you. So you don't have to go and poll. And that's a callback model. So they will call back and give you the food. So those are different ways that futures get redeemed in everyday life when you're ordering food at a restaurant that cooks your food to order. Now, you might wonder why I have a McDonald's symbol here, and that's because historically, McDonald's had a different strategy for handling load. The whole point here is to handle load efficiently relative to whatever level of service you're trying to provide. Wendy's and places that cook to order handle load by giving you a table tent number and getting you out of the way so that someone else can come up and place their order. McDonald's historically had a different approach. When you would order something, you'd say, "I want a Big Mac and fries and a Coke," or whatever. And they would have a cache of pre-cooked hamburgers or chicken or whatever you like to order, pre-cooked French fries, and pre-poured drinks. And so the clerk typically would say, "Okay, Big Mac, fries, Coke." Grab the Big Mac, grab the fries, grab the Coke, boom, there you go. And that whole transaction was done synchronously because they'd pre-cached the merchandise so you could just pick it up right away. A different approach to trying to keep things moving. I should probably note that McDonald's is trying to cook things more on demand too, to give you a fresher taste. But back in the day, they were very different styles. So the McDonald's approach doesn't have futures the way I described it. You just stand there synchronously waiting for the food, and then you go on your merry way. And the way that they keep the throughput going through the line is that they pre-cook it, so it's pre-cached. All right, so that's the concept of a future. Java futures can be canceled and tested for completion. You can say, are you canceled? Are you done? And they can be used to implement the active object pattern. And so the basic idea here is when the client invokes an operation that will run in the background, they get back a future right away. The background task does its thing in some service thread that is not the same thread as the calling thread. And basically the client can come along here and either block waiting for the result, or poll, or wait for callbacks. There's a whole bunch of different ways that the client thread can get the results from the future when it's redeemable. There are a bunch of other variants of future used in the executor service implementation. So we've got future, we got runnable future, we got future task. We'll talk about these things later when we get to that point. Future task is used to give a result from a thread running a computation to one or more threads that want to wait to retrieve it. And runnable future will allow the future to complete, and then it'll basically put its results someplace so that some other client thread can redeem them or retrieve them. There's yet another mechanism that's got the word future in it. It's called the completable future, and this is a really cool, powerful, reactive programming variant of futures that came with Java 8. We will not talk about it in this class really at all, although if you're interested, the class I teach next fall will go into this in great detail. It's really, really super cool, but it's way more powerful and complicated than the kind of futures we're going to talk about. Oddly enough, completable future really isn't part of the Java Executor framework. It was added later. It was added in Java 8. All the other stuff came in with Java 5, and there was about a 10-year period between the two. So when they added completable future, it really has a completely different look and feel to it than the other forms of futures. It's actually better. But if you're using the older versions of Java, you can't take advantage of it because it didn't come along until much later. OK, so the executor service is actually an interface that's used by a bunch of stuff. So if you take a look here, you can see we have the executor, which is an interface, and the executor service, which extends that interface. And then we've got a bunch of other things that are going to go ahead and basically implement or extend the executor service interface. Whoops. So we'll talk about this stuff later. The key point here is that we'll talk later about a scheduled thread pool executor. We'll talk about a fork join pool. We'll talk about the thread pool executor. These are all different classes that extend a common superclass called Abstract Executor Service. And Abstract Executor Service implements the Executor Service interface. So it's a very powerful, very complicated framework. Super, super cool. I don't expect you to know all the details of it right now. We will cover all these details as we go through the course. OK, so that is the end of the overview.